Hello, students. Welcome to the Basic Mathematics series. Having a strong command over basic mathematics is prerequisite for desired success in IIT Advanced, JEE and other engineering entrance examinations. Today we'll discuss about geometrical properties of parabola. This is a part 1. Part 1. So what is the parabola? Parabola is locus of the point which makes equal distance. This means this distance and this distance, this distance and this distance, this distance and this distance will be same for all the points. So the fixed point is called focus, and the fixed line is called directrix. So, and the line perpendicular to the directrix and passes through focus is called axis, and this point is called vertex. So you take any line from the focus, so this distance and this distance will same. If this is x, then this also be x. Let us have one a standard equation, that is y square is equal to 4ax. If y square is equal to 4x, then directrix equation will be x plus a is equal to 0. That means if this one is 0, 0 origin, so this distance will be minus a, and this distance will be a with respect to the origin. So suppose one point is there, that is x1, y1. So what will be the this distance? This distance will be a plus x1, and this distance also same a plus x1. So and the focus coordinate will be a0, because this length from here to here is a. Now let us come to the properties of focal chord. So what is a focal chord? So that chord passes through focus. This is a focus, a0 point passes through focus is called focal chord. And the focal chord which is parallel to the directrix is called latus rectum. What is a latus rectum? So we know this distance and this distance will be equal. So if this distance is a and this is also a, because so this distance will be also 2a. So length of latus rectum will be 4a. 2a plus 2a is equal to 4a. Length of latus rectum will be 4a. So what is the second point? Suppose here it is a standard equation, so parametrically it can be written a t1 square and 2at. So what is the coordinate of this point? So this point will be, suppose a t2 square is equal to 2a t1. So this will be t1 is equal to minus 1 by t2. So this is the relation between extremities, or you can further drive it x2. What will be the x2? X2 will be x2 will be a t1 square, a t2 square. So a t2 square means a t2 is equal to 1 by t1 square. So x2 coordinate will be a by a by x1. So a t2 is equal to minus 1 by t1. So minus 2 1 by t1 is equal to, we can derive this one by, see, we want to know the x2. So x2 is equal to a t2 square. So t2 is equal to minus, so a into minus 1 by t1 the whole square. So a divided by t1 square. Then we multiplied by a both side, a. So this one a square by x1 square. Similarly, you can calculate y is equal to 2, y2 is equal to 2a t2. 2a t2 means 2a minus 1 by t1. So this one minus 2a by t1 multiplied by 2a and 2a. So that is equal to minus 4a square divided by y1. So y2 is equal to, so this coordinate is nothing but minus a square by x1 square comma minus 4a square divided by, sorry, this is a plus 4a square by y1. y1, this is not x1, this is x, this is x. So here by a square by x1 and minus 4a square by y1. Now come to the, this is the relation with the itna. Now let us find the focal distance of this chord. What is the length of this chord? So this one we know, this one is a plus x1 and this one will be a plus x2. So length of the chord, and this one is also a plus x1 and this one is also a plus x2. So length of the chord is equal to 2a x1 plus x2. Is the length of focal chord. Now come to the focal chord as the diameter of circle. So you draw a circle considering focal chord as a diameter. So focal chord as a diameter, you draw the circle, this it will touch the directrix. It will touch the directrix. And this is another focal chord. This is another focal chord. And if you draw the circle here, you draw the circle here. So again, it will touch the directrix. That means directrix is locus of the tangents of point of intersection of the tangent of the focal chord. So this angle is 90 degree. This is also 90 degree. This is a very another important property. Now this is a focal length and draw the circle considering the diameter as a focal length. Then it will touch the y-axis. So again, this will be 90. So again, suppose if you take another focal chord, this one, at considering diameter, you draw the circle. Again, this circle will touch the this y-axis. So y-axis is the locus of this one, these points. Now come to the properties of tangent of parabola. So suppose standard y square is equal to 4ax equation, then tangent at the point this one which is having coordinate x1 y1 or 81 square to 81. So that will be y by 1 is equal to 2ax plus x1. So what is the slope? So y is equal to 2a divided by y1 x plus 2a x1 by y1. So this one is the slope. So slope of 2a by y1, and put y1 is equal to 2a is equal to y1 is equal to 2a p1, then this will cut, then this will be 1 by p1. So slope of tangent at any point x1 y1 or a1 t a1 square or 2a that will be 1 by t1. This is the equation and slope of parabola. Now put of the perpendicular from focus on tangent and image of the focus. So suppose this is a tangent, this is a tangent, and if you are drawing put of perpendicular, so previously we have seen that by this taking this diameter it will touch here, so this is 90 degree. So any of foot of perpendicular from the focus to the tangent will lie on the y-axis and make, obviously it will make 90 degree here. So if you extend this to same length, then it will touch directrix and touch it will cut directrix, and if you draw a line parallel to the x-axis, it will be the same point. So properties of parabola, we know this one is equal to this one. This one is also equal. This one is, so this angle alpha will be equal to this angle alpha, and this image will be like this. So now come to the next, that is point of intersection of the tangent. So point of intersection of the tangent. Suppose one tangent is here and this is a chord. It may not be focal chord. From here, if you are drawing a tangent, if focal chord will be there, then definitely it will cut this. So this is the point of intersection. So point of intersection will be a t1 t2 because it's a t1 and this only t2 point. So a t1 t2 a t1 plus t2. So in coordinate terms, it will be geometric mean of abscissa of this point and this point, and plus minus this sign will take as per the y1 into y2. If y1 y2 sign is positive, then we'll take positive. If y1 y2 sign is negative, then it will take negative. And in y-axis, that is not issue, it's just a schematic mean of coordinates of this point and this point. And now come to the length of tangent between the directrix and the point of contact, subtend right angle at the focus. So this is the length of tangent. So from there you draw a line to the focus, and this is line. So this will be 90 degree. This will be 90 degree. Now come to the properties of normal. So first is, any normal cannot pass through focus except this axis, because the axis is also normal at this point. So except this axis, it will not pass. And this is the normal, this normal at this point. So suppose a one parallel from x-axis line coming. So we know that it will pass through the focus. That means its normal will be bisecting this line, because reflection, Snell law से, Snell law says कि law from law of reflection, this angle will be same, and this is 90 degree with the tangent. So that means one circle can be drawn. So if circle can be drawn, considering this a diameter and this a center, focus as a center, so this length will be equal to this length will be equal to this length. That means SP is equal to SN is equal to ST. This angle made by the parallel to the axis and focal length is divided by the normal that we have already discussed. This will be alpha and this also will be alpha. Then come to the point of intersection of the two normals. Suppose one normal is drawn from the point T1 and another normal drawn from the point T2. Then this you remember, this will be the coordinates of x-axis. This x coordinate and this will be a y coordinate. X coordinate is a t1 square plus t2 square plus t1 t2, and y coordinate is minus a t1 into t2 t1 plus t2. Now come to the last property of normal. So last property of normal is, suppose this normal, this cut here and this cut here. So suppose is this a point is a t square and 2a t. So coordinate of this point will be a t plus 2t the whole square minus 2t plus 2 by t 2 by t 2 by t to the power uh, and a. So this will be the coordinate of this point. Thank you.